Okay, we have another problem here involving bearing. Ship leaves the port of Miami with a bearing of south 80 degrees east and a speed of 15 miles per hour. So it's going 15 miles per hour at this bearing. Draw that out in a second. After 1 hour, the ship turns 90 degrees to the south, and it goes that same speed for 2.5 hours. Now we want to know what's the bearing from the port to the ship. So here's another problem where we have to draw out a triangle. So first, we need to start with our south 80 degrees east. Now I want to try and draw this accurately. So 80 degrees, I don't want to draw like that. I want to try and draw it a little bit more accurately. So I'm going to draw it kind of like that. So 80 degrees is almost 90, which means that this angle right here, that would be 80 degrees. That would be south 80 degrees east, and I'll draw this out about here. I'm going to put, now it goes for 1 hour. However, instead of using, now I could use the time here if I wanted to, but I'm going to convert this into miles. So if I go 15 miles per hour for 1 hour, then that means I'm going to go 15 miles. So I'll have 15 miles here going this direction. So I'm going to go 15 miles at south 80 degrees east. Well, then it says that it takes 90 degree turn to the south. So that means that I have a right angle right here. I'm turning that direction. Now it's going to go down this way for 2.5 hours. I want to find out how far, what the mileage is going down this way. So what I need to do is I'm going to take 2.5 hours, I'm multiplying it by 15 miles per hour. So then I multiply that, the hours are going to cancel. I'm doing 15 times 2.5. If I multiply that, I get 37.5 miles. So that means that I'm going to draw this triangle here, and this gives us 37.5. So I'm going to draw it straight, and then it'll take me back to the original one. This distance right here, this is 37.5 miles. Okay, so now what I want to find is I want to find the bearing from the port, which is right here, to the ship. So I want to find the bearing, which is actually going to be, I'm going to indicate that by these two markings right here. This is the actual bearing that I want to find. So I'm going south. That certain amount, I'm going to go in this direction. I got to find out what angle that is on the inside. To do that, if I find the angle inside the entire triangle right here, what I can do then is I can take the 80 degrees minus the angle inside the triangle, and that's going to allow me to get the bearing that's going to go inside here. So that's what I want to do. I'm going to redraw the triangle and have it look like this. So I have, in this case, this is 37.5 here, and this is 15. And the angle I'm looking at this time is that angle on top. It's the one that's right by the 15 degrees. That's this one I want to find. So I want to find out what that angle is inside the triangle. So I need to get a trig function again for this. So for the trig function, I want to find one that relates the opposite. So I have an angle here. Opposite would be 37.5. Adjacent is going to be 15. So that's going to be our tangent again. I want to do tangent theta is going to equal 37.5 divided by 15. And that's what I'm going to get right here when I set that function up. Tangent theta 37.5 over 15, opposite over adjacent. I want to simplify this. I get tangent theta, that's going to be equal to 2.5. Like the last problem, I want to get rid of the tangent that's here. So what I need to do is put an inverse on both sides. So hopefully you have this problem down on and make a little extra room here. So that way you can see it bigger. Tangent theta is equal to 2.5. I want to put an inverse on both sides. I'm doing inverse right here because, again, that's how I want to cancel out the tangent on the outside. If I put an inverse on both sides, it'll cancel that out there, and therefore I'll just get theta left over. Theta is equal to inverse tangent of 2.5. So when I have that, inverse tan 2.5, I'll put that part in my calculator, and that's going to give me the angle that we're going to be using here. So in this case, the angle that we're going to get is going to be 68.2 degrees, inverse tangent of 2.5. Now that's not going to be the answer to the problem. All we did was we found 68.2 is going to be that one. But if I want to find this one on the outside, I got to take 80 minus the 68.2. So now what I'll do is I want to write the actual answer. And so it's going to go south is the direction on that one. That amount of degree it's going to go here will be in the middle. Now what I'll do is I'll take 80 degrees minus 68.2 degrees. I'll have that kind of in the center. And then it's going to go in the east direction. So this is what it's going to look like. I go south, this angle inside here, and then I go east. Well, I have to now just subtract that, and when I do, I'm going to get my final answer, which is going to be south. I get 11.8 degrees east. So that's the measurement that's going to go inside there. South, 11.8 degrees east. This would be your final answer. That's our bearing.